sharing. So he come to the next talk. Giri, developer advocate, office of the CTO at Solus. He will be talking about how to bridging the gap between the design and runtime in EDA with AsyncAPI. Thank you.
Hello, my name is Giri Venkatesan. I'm a developer advocate at Solus. I want to thank apidays Connect Hong Kong 2023 organizers for giving me this opportunity to talk with you on the topic of bridging the gap between design time and runtime in EDA with AsyncAPI. What is event-driven architecture? Event-driven architecture is a software design pattern in which decoupled applications can asynchronously publish and subscribe events via an event broker. With that said, when it comes to system design and development, iterative development methodology is the most popular one and most adopted one, and EDA can benefit from that as well. The benefits are many: early feedback, continuous learning, faster value delivery, alignment with agile practices that you may already have in place within your organization. In EDA, we start with event storming, basically a collaborative workshop technique used to model and understand complex business domains and processes. It involves bringing together stakeholders, developers, architects, and domain experts to create a shared understanding of how events flow through the system and how the components interact with each other. The goal is to uncover and visualize events, commands, and business processes within the system. That's a starting point. And then refine the design and design decisions based on the continuous feedback on each of the iterations. And one thing to notice, the event storming sessions can be held periodically to revisit and refine the shared understanding of the system's behavior and identify areas of improvement in subsequent iterations. Okay. Now, when it comes to EDA, the implementation would produce a set of design time and runtime assets. The separation is essential as it allows clear understanding of each phase's responsibilities and characteristics within the system's lifecycle. From a design time perspective, the assets produced are application domain, a grouping of related EDA artifacts such as applications, events, schemas into a logical category, maybe by a line of business or a team or a type of service and so on. And then application, a process or a microservice or an integration component that is either a consumer or a producer or a processor of events that interacts with the event broker. Event is a fundamental unit of information that flows across the system and defines the properties and describe and categorize actual event instances at runtime. Obviously, schema is equally important. The structure and meaning of the data carried in the payload of an event so that the publisher and subscriber have a common understanding of what each value means. Right? Now that that's the design time. From a runtime perspective, obviously, there are other aspects like topics, queues, and consumers that can come out of the design phase that could be pre-created. Okay? From a runtime perspective, the operational environment or the execution environment is equally critical. It represents the operational environment within your organization meant for a particular purpose, like development, staging, testing, production, and so on. And then you have the real place where the action takes place. That's an event mesh, an architecture layer where the real action takes place, representing a network of interconnected brokers to support the event distribution in real time. Okay, and messaging service and interface to the broker to manage the policies around the transport, authentication, and security. Event management agent, basically a runtime component to discover event streams flowing through your brokers as well as related configurations. Okay. So let me introduce two key concepts that are essential, basically essentially a game changers in this bridging the gap. Right? When it comes to EDA system design, the first one is Solus Plus Event Portal, and the other one is the AsyncAPI. Let's see what they are. PubSub Event Portal is an event management tool that helps you visualize, optimize, and govern event flow across your distributed enterprise. It helps you design events and event-driven apps with the best practices inbuilt. Discover and catalog the events across the business. So that's the purpose, right? So more on the design time activity. Now, what is the role of AsyncAPI? First of all, AsyncAPI is an open source initiative to improve the state of EDA. That's the goal. It is basically to make it easy for you to build and maintain EDA. It does so by offering these two aspects: the specification, basically a standard for documenting your event-driven microservices, IoT APIs, streaming APIs, or anything that is basically asynchronous nature. And then the tooling ecosystem, the tools to create these async API documents, and then generating code from that, parsers, visualizers, and so on. Async API is becoming industry standard for defining asynchronous APIs. That's the current state, right? When we talk about assets generated in your development activity, we surely want them to be lifecycle managed for better access, visibility, and control. Now we are venturing into the realm of SDLC, right? For the past decade, many of the enterprises have invested lots of blood, tears, and sweat into building these software development lifecycle processes that meet their unique requirements. Tools like GitHub, Jenkins, Ansible are now crucial for moving services from concept to production, while the tools like IntelliJ, Postman, and others help developers to become more productive. Unfortunately, event-driven architecture tends to bedevil these tools and the processes that IT teams build around them. With widely shared events and common infrastructure like event brokers in EDA, it can become harder to anticipate, manage, and prevent conflicts during SDLC. Okay. Only in absence we truly appreciate the treasure of presence. On that note, let's examine the issues that can stem from the absence of SDLC. Okay. Incomplete requirements gathering, inconsistent design approaches, lack of documentation, and so on. How about in EDA? This entire list is so true for EDA as well. But I want to call out and focus on 4 distinct points relevant to EDA. First one, lack of governance of shared resources lead to chaos. That means you will encounter resource conflicts, scalability issues, and security risks. Then lack of visibility into existing events create duplication and overhead. Basically, issues around data integrity, duplication, resource wastage, inconsistent state and behavior, and harder to track what's happening in the system. And third one is lack of visibility into event flow impacts the organizational planning. That is essential for future proofing, right? This can lead to increased uncertainty, increased inaccurate planning, uninformed decision, and potentially missed opportunities. The last one, the most important one, lack of ability to expose events for reuse prevents collaboration. That's one of the fundamental tenets of modern software development, right? So such a inability would result in siloed development, duplication of effort, and overall slowdown in the pace of your development activities, which none of these things are desirable. Okay. With PubSub Plus Event Portal aiding the design, development, and management of your EDA, we can use Async API to document the services or applications that can be managed within your scope of SDLC. Right? With Event Portal's extensions to SDLC tools like Slack, Confluence, IntelliJ, GitHub, Jenkins, and so on, right? Your team can seamlessly collaborate and operate with ease, guided by your existing organization's SDLC policies and processes. Okay. So I want to include a quick demo on this. Let's take a simple online ordering service that's built using EDA, right? And we're going to consider a small subset of operations. And we shall have applications around basket service to collect orders, order review, order validation, and order placement. Okay, so we get our EDA built using Solus PubSub Plus Event Portal, and then we pick one of the services, for example, basket service, and download the Async API document, put it through the Async API code generator to generate code, and now you have an EDA microservice that can talk to Solus or a Kafka broker, right? So now, definitely, since we're talking about code, we want to make sure that it's a version controlled. It's checked into a source control system. So GitHub is a choice. So we push the code to the GitHub. As part of the code, we can also push the Async API document that's used to generate this code into the repository. That's great. Now, GitHub opens up new opportunities. We can define CI/CD workflows to take some actions. What could they be? We can have a workflow that checks for the presence of Async API document in any of the files and do a validation. If it is found to be valid, merge it. Otherwise, prevent merging from happening. That's one possibility. The other one is when you create a PR and make changes to the AsyncAPI document because the code has changed, right? You can have a workflow to check the presence, validate it, on top of it, see if it is different from the existing version. If yes, then call appropriate PubSub plus event portal REST API to push the changes to the event portal. So essentially, you are updating the design time asset based on the changes made outside the event portal. So we're talking about a full circle, uh, keeping the design and runtime activities in sync. Okay, so let's dive into the demo. All right, let me introduce you to Solus PubSub Plus Cloud. The first thing first, if you want to create a trial account that's valid for 60 days with access to all the exceptional features of Solus PubSub Plus Cloud, feel free to do so. I would highly encourage it. And I have an account, so for that purpose, just simply going to log in. Right? Let me quickly walk through the event portal, what it offers. So it's a collection of tools that helps you build and manage your EDA in a single place, right? It contains tools like Designer, basically designing your EDA, and then the catalog, basically search for event schemas for across your enterprise for viewing, sharing, and so on. Runtime event manager, which we talked about, cluster manager, mesh manager, and so on. Right? The first thing, if you create a trial account, the first thing that you need to do is create a broker service, right? So where you get to specify the name of your service and then the cloud hosting location, the provider choice, AWS, GCP, and then the location where you want it to be hosted, and so on. And that will entitle you with a broker, right? And how do we connect to the broker? So there's a set of guides here. If you're coming to Spring Cloud Stream, for example, which is something that we'll be using, we can get the credentials for connection and also the host URL where you'll be connecting to. Okay. Obviously, our broker supports various protocols, so you can view by protocols as well. Okay. And also a quick note on this, without writing any code, if you want to simply test out the PubSub in action, you can use this try me tool to publish an event on a topic. For example, connect here and connect here. Now I have publisher and subscriber, right? I'm going to subscribe to this topic, try me, and from here I'm going to publish an event. You can see it being delivered to the subscriber, right? So this tool will come in handy to verify the PubSub activities without writing code. The next thing I want to showcase is, let's go to Designer. I've already created this EDA for online services that we discussed as a demo scenario, right? In that, I have 4 applications and 6 events and schema for each of these events and an enumeration. Okay, let me drill into this particular application. So this is the one that we're going to use for our demo scenario. So I'm looking at a version 0.10. That simply means that we can have multiple versions of this application. And by the way, each of the resources that we are talking about here, application, schema, event, all of them are versionable, okay? And you can maintain the state of the version. You can have it as released, deprecated, retired, draft, and so on. So you have the state management inside this resources. When you're looking at the application, simply we see what are the events that the application can publish or subscribe to. In this case, there is no subscription event set, but it can publish an event called basket version 0.10 on this topic. A note on this topic is Solus topics are not simply literal strings. It supports a hierarchical multi-level topic representation, with each level being able to bring out or represent some information about the event context. So retail Acme online basket, right? That's good enough context. But then on top of it, what is that event is corresponding to? So is it an order creation or order validation or order update? So we can create an enumeration encompassing these 3 values and put that as a value for this particular level. And then we are looking at a version 1 of this event and an unbounded variable, basically the order ID that would be populated at runtime when the program runs, right? And let's dive quickly into this event. You see the event properties, the topic it operates, and any other references like applications that are publishing or subscribing to these events and so on. So the key thing to note is event can have a reference to the underlying schema. Basically, the payload that it carries will correspond to this schema, right? So it can be of JSON, Avro, or any type. Right? If I drill into schema, you get the full schema definition. Okay. So at this stage, let me go and generate this AsyncAPI document for this application. I'm choosing the existing version. I want a JSON representation, and I will store it as basket writer 010.json. So in next step, what I'm going to do is I'm going to put this AsyncAPI file through AsyncAPI code generator to generate a Spring Cloud Stream microservice. So we see that in the next step. Okay, so the first thing first, I created a GitHub repository, apidays.hk 2023, and then so the AsyncAPI file that we downloaded is in this directory, basketwriter010.json. So I ran this AG command, basically AsyncAPI code generator, by specifying all the requisite parameters, like from a package perspective, as well as the connectivity information, like the host URL, username, password, message VPN, and so on, and the template that I want to use. The service that I want to generate, the code I want to generate here should be for Spring Cloud Stream framework. So if you check out the async API generator, right? Here's how you download the tool using npm install, and you run the AG command, right? So if I go to async API GitHub, you can see these are the templates available. You can generate code for PHP, .NET, Python, Java, Spring Cloud Stream, Java, Node.js, and so on. So we chose to go with the Spring Cloud Stream. So this produced a project for me, and I've already imported this in my IDE. And I made a first commit. But before doing the commit, what I did is, I added the workflow that I was discussing. There are two workflows that I'm adding into this code base. EP merge to push the changes detected on the async API file into Solace event portal, and then another workflow to detect the presence of async API file and validate it. Okay. So that's one change. And in the application, it would have produced a general scaffolding code without any business logic, right? So I kind of built the business logic over here. It's nothing but create a basket, with order details, the price, quantity, product ID, customer ID, and so on. And I also have a scheduler, that runs every 10 seconds, create an order and publish it. So the publishing happens here. It uses string bridge to publish the event to the broker, and published event gets ordered on this topic, retail Acme online basket. And then this placeholder will have the value such as whether it's an order creation or order update and so on. And then the last one carries the actual order ID. So this one is done, and then I push it to GitHub. Now let's see what the code has. There we go. And it also has GitHub workflows. Back to this. Okay, so looking good. Now in the next step, let's run it now. So every 10 seconds, it would create a random order. So when it starts publishing the order, I'll show you the event getting published to the broker, and you'll use the try me to subscribe to that event. All right, so let it happen. I'm going to go to console. Here's the try me. I am going to bring in that event name. So connected to the broker. So we use wildcard subscription. We can have any value on that level, created, updated, validated, whatever it is we want to capture. And then for any order, so we use a wildcard star So now we have a subscription, right? And there we go. We start seeing this event. Jumper quantity 7, price 20, customer ID, and so on. Okay. So let me disconnect and keep it ready for the next step. So at this stage, we saw the Spring Cloud Stream microservice, the code generated using AsyncAPI code generator from the AsyncAPI definition we downloaded from the event portal in action, right? So as a next step, what we'll do is we will make some changes to the logic over here. That would be around checking the order quantity and see if it is a risky order, as in maybe the quantity is 0, not acceptable, or quantity is more than 5, not acceptable. So in that case, we want to generate another event and publish it to the broker. That would be same hierarchy, retail Acme online, risky basket. That's how we're going to differentiate, and it will carry the same information in terms of payload. Right? So that's a change that we are going to do. And now that we have our Git workflows in place, we should be able to see the kicking. Before that, one other thing that I will do is I will make the async API file definition part of this code base. Okay, so when I make that as a part of the code base, and when I create a branch and add these changes and then push it in, the workflow will kick in to detect presence of async API file and validate it. Okay, and when I confirm the merge, it's going to take that file and do a diff with the existing version in the repository. And if it found to be modified or changed, then it will push the changes to the event portal. That's what we're going to see in the next step. In this step, what I've done is a couple of changes. First one is, in my application, I added additional logic to check if the quantity is equal to 0 or greater than 5. If yes, publish a different event. And that event will have a topic of retail Acme online risky basket. And I was able to generate an updated async API file, and I have it here. So this code, I'm not checking into the main branch. Rather, I created a new branch called feature risky basket implementation, and then I push the changes to that branch. So the goal is to see that the changes are detected upon merging, and automatically the workflow to sync the designer, the event portal objects kicks in. Okay, so let me quickly run this to show you that the risky basket events are generated. So I already have the subscriber ready, subscribing to both basket and risky basket event topics. Let's see. There we go. Event created. Okay, since the quantity is 1, there is no issue. Let's wait for the next event. Hopefully, yeah, it is 11. So you can see that it is having a risky basket event published alongside this one. Okay, so that's about the change that we made, and it is very effective. And let's go to examine the GitHub. So we have this, let me go here, actions. So when I checked in to the feature risky basket implementation, it checked for the presence of the async API file and did a validation. That test passed. That's the first workflow. And then when I approved the merge, again, it detected the presence of async API document and found it to be different from what is there in the main branch. So it then called import async API file. This step would have updated the event portal with the changes. Let's go and check it out. So online services. Yeah, as a starter, the application got a version bump. Now we have 2 versions. And then when I go into this version, we can see this application version is now publishes 2 events, can publish 2 events, basket as well as risky basket. Essentially, what you're seeing is a full cycle of starting from event portal, using async API to generate the code, make changes to the code, generate an updated async API version document, and then push that into GitHub. In this entire process, the GitHub workflows comes in handy to validate the async API file, and then if found to be different from what is there in the repository, call the event portal API to push the changes into event portal. So we have managed the bridging of gap between the design time and runtime as a quick example. The closing thought, I just want you to make some time, and if you can, join our Solace community, where topics around EDA, AsyncAPI, and all other relevant things are discussed. We will be happy to answer your questions and help you with anything. Thank you for the opportunity to talk to you today.
Thanks for the wonderful sharing about the Async API. So he come to the last talk in this section. So let's welcome Newman Ali, Product Manager at Soplight. Here we will be talking about the governance for API design at scale.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.